This is our chemistry project, and we are the Adams family. Alright, I'm Ryan, and I'm part of the Adams family. And the equation that I'm doing is for problem number 59, which is, it says if there's 40 grams of iron oxide react with 10 grams of magnesium, what is the mass of iron that will be produced? So basically we're going to start out with identifying our knowns. So we have 40 grams of iron oxide, and we have 10 grams of magnesium. And what we're going to try to figure out is how much iron comes out of both of these. So this is going to yield here, this is going to yield here. So we're going to fill in a blank here and fill in a blank here. Okay, so the first part we're going to do is we're going to do the 40 grams of iron oxide. So we have 40.0 grams of iron oxide. And what we need to do is figure out how much the total mass of the iron oxide is. So we have to add our 55.85 and our 16 to turn that into moles. So we're going to multiply by 1 mole of Fe(O), and then that is going to be 71.85 grams of FeO. Okay, and from there we're trying to figure out how much iron we have. So what we'll end up having is something over, and then we're going to have the 1 mole of iron, okay, and then we're going to have 1 mole of iron here, and then we're going to have equals how much Fe. Okay, so from here we know that the weight of the iron is 55.85, so 55.85 grams of Fe equals 1 mole. And then we can put same thing over here. This is the 1 mole of the FeO. So basically it's set up so that way we have 40 grams of the iron oxide multiplied by 1 mole of the iron oxide divided by the mass of it, which is 71.85 grams of iron oxide, times 1 mole of iron divided by 1 mole of iron oxide. And then we're going to multiply that by the 55.85 grams of iron, and then divided by the 1 mole of iron, which will give us our total iron that is produced from 40 grams of iron oxide. So if we write it out again, we have 40.0 times 1 times 1 times 55.85. All of this divided by 71.85 times 1 times 1, and this will yield 31.1 grams of iron. Okay, so we know that 40 grams of iron oxide will now yield 1.1 grams of iron. Okay, so the next part we have to do is do 10 grams of magnesium, and we're going to find out how much iron is produced from that. So Fe. Okay, so we're going to erase this. now we have 10 grams of magnesium, and then we're going to try to figure out the molar mass of that. So 1 mole of magnesium equals 24.31 grams of magnesium. Okay, and then our end result over here on this side is how much iron we're looking for. Okay, so we need to find out how many moles of magnesium goes into moles of iron. So we're going to have 1 mole of magnesium and 1 of iron over 1 mole of magnesium. Okay, and we're going to multiply that by the iron, which is 55.85 over grams of iron over 1 mole of iron. So basically we can go back and go through. So 10 grams of magnesium, so we can cancel our magnesiums here. Okay, and then 1 mole of magnesium, 1 mole of magnesium. Okay, 1 mole of iron, 1 mole of iron. So we're left with 10 grams of magnesium to 55.85 grams of iron equals how much iron here. So when we rewrite that out to enter into a calculator, 10.0 grams of magnesium. Sorry, we'll just put this is going in the calculator. So 10 times 1 times 1 times 55.85 divided by 24.31 times 1 times 1. And this yields 23.0 grams of iron. Okay, so that we can write up over here, 23.0. Okay, so now that we've calculated that 10 grams of magnesium will yield 23 grams of iron, we know that 40 grams of iron oxide will yield 31.1 grams of iron. So basically we know that our reactant of the iron oxide plus the magnesium will yield a product of our iron and our magnesium oxide. So we know that our excess will be we'll have excess when we have 40 grams of iron oxide, which will yield 31.1 grams of iron, whereas only 10 grams of magnesium will yield 23 grams of iron. So therefore, the limiting reaction will be the 10 grams of magnesium will only yield 23 grams of